Last time, AI learned to see beauty, to judge similarity, to point at a target. But physics ignores all of that and asks only one thing: does it work? Here's the trap. AI can invent a million candidates in seconds, geometry after geometry, effortlessly. But physics tests them one by one, each check taking minutes, pass or fail. Generating is cheap. Evaluating is the bottleneck. And behind every candidate sits a slow pipeline. You draw the geometry in seconds, then you solve Maxwell on a mesh, 20 to 45 minutes. Only then do you read the result. Seconds to propose a design, minutes to know if it works. Language models never had to wait this long for an answer. A chess engine reuses everything it has ever learned. Physics doesn't work that way. Nature doesn't remember yesterday's winner. Every design starts from zero. Passing test A tells you nothing about test B. And what we're shaping isn't really the metal, it's the field the metal shapes. The geometry steers a standing wave into resonance. We don't really design metal, we design electromagnetic behavior. The shape is just how we steer the fields, and fields obey Maxwell, not intuition. Now multiply that by every tiny tweak. Shift one gap by 1/10 of a millimeter, and wait 45 minutes again, then again and again. A small change carries a big cost, thousands of times over. This is why language AI raced ahead and physics AI didn't. Language gives feedback on every token, instant, free, billions of signals per run. Physics gives you one answer per simulation, once every 45 minutes. LLMs improved fast because correction was cheap and constant. In physics, every lesson is expensive. So the fix isn't a bigger model, it's cheaper feedback. Surrogate models predict the result in milliseconds. Neural operators learn the whole field map. Designer-inspired RL rewards designs that actually work, and active learning only simulates what the model is unsure about. Each one replaces a 45-minute solve with a near-instant estimate. We're not trying to replace physics, we're learning to need it less. The solver stays the source of truth. AI just asks it fewer, smarter questions. So 4 things make physics hard for AI. Nature is complex, feedback is expensive, iteration is slow, and intuition is hard. There's no gradient to follow by eye. This is why physics is hard for AI, not a lack of intelligence, but a lack of cheap feedback. But the path is clear. Make each answer cheaper and the whole design loop speeds up. When feedback gets cheap, engineering AI takes off, the same way language AI did. So here's the takeaway. Language AI took off because language gives cheap, instant feedback. Engineering AI will take off when physics gives cheap feedback too. The future of AI in engineering starts with cheaper feedback.